Alright guys, so we watched this clip, and the whole reason why we did that, besides it was fun, is because I want you to tell me, if someone's taking a penalty kick, what angle do they have to kick it at to hit the post? Now let me just back this up a bit. If I go and I kick a ball in the air, what shape does it make?
A curve?
It makes a parabola, okay?
Parabola?
Yeah, it makes a parabola, a curve.
Is that a fancy word for curve? Yeah.
Now, is this technically going to be a triangle? Well, let's assume he was kicking it hard enough that it was still considered linear, okay?
It's like, that was a
because it's linear initially, but once gravity comes in, then it starts to curve, right? So, we're going to assume this makes a right triangle. Now, soccer goal is 8 feet high, and then you're 12 yards away. A yard is 3 feet, so it's 36 feet away. What we want to do is we want to use what we've learned about SOHCAHTOA to try to figure out what this angle is right there. Does that make sense?
Since it's a right triangle, we have 90 degrees, and we're trying to find theta.
So, what we're going to do now...
No, we're trying to find hypotenuse.
No, we're not finding how far the ball is. What we're trying to find here, which is why this is a little bit different, we're trying to figure out theta, this angle right there. But we're going to approach this the same way, guys. We're going to say, all right, how would you label 8 and how would you label 36 if we're doing opposite adjacent hypotenuse? Don't shout it out, but I want you to just label your own picture in your notes. How would you label 8? How would you label 36?
8.
Whoa.
No, I was talking about the numbers. They're both in feet, right?
Yes, these are both feet. Okay, now you can tell me, guys, how would you label 8?
Opposite.
Opposite. How would you label 36? Adjacent. And now what we're going to do, guys, is we're going to say what trig ratio uses opposite and adjacent. It's a tangent. So how we would set this up, and give yourself some space here. I'm going to put tangent of theta.
A lot of space?
And then this is where you give yourself some space, is you're going to put 8 over 36. But see how I gave myself some space? You'll see why. Now, what I'm going to need to do here is I need to get rid of this tangent, because I want to know what theta is. Now, when we've been solving before, we're like, if something's timesing, you just divide it. If it's adding, you subtract it. You do the opposite. What's the opposite of tangent? Well, tangent is acting on it, so I can't divide by tangent. That doesn't make sense.
The opposite of tangent, cosine.
No, it's not. Good
Sine.
guess. Hey, watch this, guys. Let's say I was solving something, and I said I wanted to solve the square root of x equals 2. What's the opposite of a square root?
A square?
Squaring, so the square cancels the square root. Squaring and square roots are inverses of each other.
How am I going to tangent it?
So we need to find out what is the inverse of a tangent, and it's actually just called the inverse tangent.
I remember this.
If you look on your calculator above tangent, do you see in blue where it says tangent to the -1? That's called the inverse tangent. And if I take the inverse tangent of a tangent, they just cross each other out. They cancel each other out. However, if I take the inverse tangent of one side, then I need to take the inverse tangent of the other side. So what I'm going to have here is I'm going to have theta is equal to, and then you guys on your calculator, you're going to do inverse tangent of 8 over 36.
We have theta.
Now, what you're going to do is you're going to push second tangent, 8 divided by 36. Don't shout out what it is yet, but you can check with your neighbor if they get the same thing when you do inverse tangent of 8 over 36. All right, now you can shout out. What'd you get?
12 and a half.
12 and a half what?
12 and a half theta.
What are degrees measured in?
Degrees?
Or angles, what are angles measured in?
What are degrees measured in?
Hey, so this is an angle. Now what this means is that if he's going to kick the ball and he's hitting it hard enough that it's linear, if he kicks it at 12.5 degrees, that's where he's going to hit the post. What if he kicks more than that?
It's going to go over.
It's like the Uruguay guy who skied it, right? What if he does less than that? Then that's where you could possibly score, okay? All right, so this is how you find a missing angle. You're going to use inverse sine, inverse cosine, and inverse tangent. Does that make sense?
Yes.
let's do an example. We're doing 2 here, and then we're going to do 2 solving, and then we're done. So looking at number 1, I'm going to set this up the same way. I circle my angle and say, okay, I'm trying to find that angle, and I'm going to then try to figure out what is opposite, adjacent, and hypotenuse. The 2 is across from it, so it's opposite. The 3 is next to it, so it is adjacent.
Another.
And then I'm thinking SOHCAHTOA, which trig ratio uses opposite and adjacent? And you would say? Tangent. Good job. So I'm going to write that out. Tangent of theta is equal to, and then give yourself some space, opposite over adjacent, which is 2 over 3. Now, why are you giving yourself some space? What are you going to do next?
Tangent to the negative.
Exactly. You're doing the inverse tangent. Because I need to cancel the tangent, so I'm going to do the inverse tangent. But if I do that to one side, then I've got to do that to the other side. The inverse tangent of the tangent, it just crosses out. So I'm left with the angle, theta, is going to be the inverse tangent of 2 over 3. And that's where I'm going to go and put that in my calculator.
33.69 or 33.7.
Let's go to the nearest tenth. That's what the instructions say, so let's go to 7. So that'd be, Eleanor said 33.7. Does anyone agree? Did someone check that already and confirm that?
Yeah.
All right, thanks, Melissa. So good job. So our missing angle there is 33.7. What I want you guys to do now is to try number 2 with your neighbor. Circle your angle, label your sides opposite, adjacent, hypotenuse, figure out which trig ratio you could use there, and then do the inverse on both sides. Give it about a minute. Let's see how you do.
For 2.
Actually, since these are right triangles, since we have the 90 and then we get the other 2, we can actually figure out the last degree by adding the other 2.
We're going to see that next. Good comment. All right, let's go over this together, guys. So I'm going to circle this. How did you label 6? How did you label 7?
6 was opposite. 7 was
Yep.
the hypotenuse.
So Skylar, which trig ratio did you use?
I used sine.
Good job, because it's opposite over hypotenuse, so great. So I'm going to say sine of theta is 6 over 7. Were you guys able to get that set up? Does that make sense why it's signed? Do you have any questions there?
Oh no, I was looking at the right thing, but I thought I was looking at the right thing, but I thought it was cosine. I was looking at the right.
Oh. Yep, so we got to double check. If it's opposite and hypotenuse, use sine. And then to get rid of a sine, we use the inverse sine, just like we got rid of tangent by using the inverse tangent. So now, you're going to go on your calculator and do inverse sine of 6 over 7. What angle did that give you guys?
58.99 or 59.
Do you guys agree with 59?
Yes.
Awesome job. That's how you do it. Now some of you guys, while you're doing this, were like, oh, I remember this. So if you remember it, great. I hope it's coming back. If not, I hope it makes sense. Okay, so that was how you find missing angles. Now we're going to put it all together with what we call solving a triangle. When you're solving a triangle, you find all the missing sides and all the missing angles. We're going to do 2 examples because there's one of each, okay? There's like 2 types, so we're going to see that here. So, let's look at this first triangle here, and I want you to tell me what don't we know. What is missing for this triangle?
The long leg and the short leg and B.
There we go. So we're missing angle B. Now, guys, angles are always capitalized. So you got angle A, angle B, angle C. They're
So-
capitalized.
Is 22 supposed to be angle A?
Yeah, it's just
Okay.
too small to write right there. So the angle A is 22. Now, the sides are lowercase and they're always across from their angle. So here's A. So side A is going to be right there. We know side C is 8, but we don't know side B right there. So we need to figure out angle B, and then we need to figure out side A, and then we also need to figure out side B.
We could do the angle pretty easily.
Okay, now pause on there. So Eleanor was telling me just barely, she knows of a slick way to figure out the angle where you don't have to use inverse trig. Before we talked about that, is there anyone else who sees how we could easily figure out angle B?
Can I say?
Yes, you can. Go ahead.
We have a 90-degree angle because they have these are 90-degree triangles. So we have 90 degrees and the 22, and if the whole triangle is 180, right? Then we just add 90 and 22 and subtract 180, and that's the last angle.
There you go. So guys, all angles, it's called the triangle angle sum theorem. All the angles add up to 180. So let's take 180, and yep, this little red rectangle means 90. What's 180 minus 90?
127?
No, just 180 minus
Oh.
90. It's half of it, so it's 90, right? So I have 90 degrees that the two other angles are going to split. So I'm going to then take off 22, and according to my math, that's 68. You guys agree?
Yeah.
So that tells us that angle B is 68 degrees. So did we have to use any SOHCAHTOA there?
No.
So if they give you two angles to the third, you just subtract it from 180. You got it. That's pretty easy. Now, let's start by finding A. So I'm going to kind of label my notes so you know what I'm doing. I want to find side A. Do you guys want to use 22 or 68? It doesn't matter.
Wait, for what?
For what
Oh,
angle
for
we're
angles?
looking from.
Oh,
22.
22. So we're going to go from A's perspective, which is 22. So if I'm looking from A's perspective, how do we label side A, side B, and 8? Well, 8 is pretty obvious. It's a hypotenuse. How would you label side A? Because it's across from it. And how would you label side B? Because it's next to it, right? Now, if I'm trying to find A, that's the opposite side, and I'd have to use a hypotenuse because that's 8. I can't use A and B at the same time because I don't know them. I have to know one of them and find the other. So if I'm finding A, I'm going to use the opposite and hypotenuse, which means, which trig ratio are we going to use? We're going to use sine, because why? Because it's opposite and
Oh, I
hypotenuse.
thought we were doing opposite.
So if we're doing SOHCAHTOA, we're going to use sine, because opposite hypotenuse. So the sine of 22 is equal to opposite over hypotenuse. In this case, that is A over 8. Okay, that's how we set that up. What am I going to do on both sides to solve?
Multiply by 8.
Yeah, that's times by 8 on both sides. And then you guys on your calculator, you're going to put in 8 sine of 22. And what does that give you?
2.99
Yeah, let's just round that up to 3, shall we? So side A is going to be 3, whatever we're working in. Yards, miles, whatever. Okay, so that's cool. We've got side A. What is missing now? Side B. So now I'm going to change colors here a little bit. So I'm still going to go from A's perspective, but now I want to find B. That's my adjacent side. I could still use the opposite, but I like the hypotenuse just because it's right there. So guys, what trig ratio uses adjacent and hypotenuse? It's going to be tangent. So I'm going to put some notes here. This is how I'm going to find side B. And, sorry, I don't know if I heard you quite right. Which one are we using for adjacent and hypotenuse? So that would be opposite and adjacent. So, if we look at SOHCAHTOA, yes, there we go, good job. So if I do cosine of 22 degrees, then that's where I'm going to get adjacent over hypotenuse, which is B over 8.
Really have to multiply by 8.
that's going to be what we put in our calculator is 8 times cosine of 22.
7.4.
And let's check that. Can someone confirm 7.4 is equal to B?
Yes, sir.
You can confirm. Awesome. So 7.4 is equal to B. So I'm going to come right here and put B as 7.4. So guys, now we know all of the sides. We know all of the angles. Now let's say you were like, well, I want to check to see if I did it right. Do you remember the relationship between the sides in a right triangle and some theorem you learned?
If they all add b squared plus c squared equals a squared plus b squared equals c squared.
So in a right triangle, if A and B are your legs and C is your hypotenuse, then A squared plus B squared equals C squared. Let's check if that is true. What is 8 squared?
64.
Let's take A, we said it was about 3.
Yeah.
And then B, we rounded to 7.4. Let's do 3 squared plus 7.4 squared. Does it get you close to 64?
Probably.
Well, it's got a calculator.
Well,
What'd you get, Melissa?
yeah, I haven't done it yet.
Oh, okay.
I mean, like, I trust you. It's 63.76.
Why is it not exactly 64?
Because it's not exactly 3, or it's not exactly 7.
We rounded, right? We didn't use the exact value. Okay, now I still want to go over the second example because it's a little bit different. Before we dive into it, how is this second example different from the first example?
It gives us no angle.
We have 2 angles over here, but we only have 2 sides over here.
There we go. So I'm going to kind of divide my page here and come over here. So before, we had 2 angles given, and that made it easy. Now, I don't know angle A, and I don't know angle B. Also, which side do we not know?
Your A.
It's side B, because it's always across from its own angle. So if this over here, that would be called side B.
Okay.
You could also call it side CA and connect the angles, but I think it's just easier to write it like that. And I think that's how it's more likely to appear if you had a question like this on the ACT.
What angle are we trying to find? All of them?
We're going to find A and B. So this is how we're going to start. Let's actually just start with A. Now, in order to find angle A, we need to use 2 of the sides that we know. So how would we classify 5 and 15.9 from A's perspective?
Opposite and hypotenuse.
5 is across, so it's opposite. 15.9 is next to, so it's, what is it?
Sine.
So hold on, we don't know the hypotenuse. What is 15.9? Oh, wait, yeah, it is the
Yeah, we do.
hypotenuse. Sorry, for some reason I was thinking B was the hypotenuse. I was seeing if you were paying attention. Okay, so here we go. That is going to be sine because it's opposite hypotenuse. You guys okay with that?
Yeah.
So I'm going to write the sine of A, because that's the angle we're trying to find, is equal to opposite over hypotenuse, 5 over 5.9. And I'm giving myself some space because I know,
15.9.
yep, I know when I'm doing the, to get rid of a sine, what do we need to use, guys?
Sine to the power of -1.
So I'm going to do the inverse sine of both sides.
This is like a not angle. I don't like this. Oh, it's because I did regular sine. I'm like, this is like 0.0 decimals.
Yeah, now one thing to keep in mind, if you're getting answers that don't make sense, do you know what the most common error is?
It's not doing squared sine.
You're in radians.
Well, that's
So
what we gotta
always check your mode to make sure you're in degrees. Alright, so now help me out here, guys. What did you say A was? If I do the inverse sine of 5 over 15.9, what is it?
18.32.
Degrees, right? Because that's our angle. So A is 18.3 degrees. I'm going to write that in here. 18.3 degrees.
And now we just cheat and add it up to 180.
Yes, that's the next point, guys. So if I want to find B, which is next, could I go through and do inverse sine, or like here it'd be inverse cosine? Sure, but is there an easier way now that we know 2 of the angles?
Yeah.
What is it?
A 180 minus 90 minus 18.3.
All the angles in a triangle add up to 180. We know the angle C is a right angle, which is 90, so we're going to take that off and it gives us 90. What did we just find the angle A was? 18.3. So if we do 90 minus 18.3, that's going to give us angle B, which I believe is that 71.7? Someone check my work there.
Yeah, it is.
Awesome. So
oh, yeah.
now we got angle A and angle B, and we got B kind of fast. But what if we had used inverse sine or inverse cosine? Would we get the same answer?
Yes.
Yeah. So either way is good if you were feeling like you wanted to do inverse cosine. Okay, now last but not least is we need to get side B. We know all the angles, so we could go from whatever angle we want. Okay? Let's just ask Brian, what angle do you want to go from, Brian? Because B for Brian, right? I had a feeling you were going to say that. Okay, so what we're going to do is we're going to go from B's perspective here, and we're going to try to figure out side B. How would we label side B from B's perspective?
Opposite.
It's the opposite. Now, I already had an opposite here because I was looking from A, so I'm going to erase that. B is the opposite. And Brian, would you rather use 5 or 15.9? How would we classify 5 from B's perspective? Yeah, that's our adjacent because it's next to it. So for us to find side B, what trig ratio are we going to use? We've got opposite and adjacent here. What trig ratio uses opposite and adjacent? So TOA is...
10.
Is that what you were saying under there? I heard...
Yeah.
Like, it was kind of like muffled, so I couldn't tell. So, tangent of which angle we're going from B. What is B's degree? No, hold on. What,
Wait,
what,
no.
I'm asking you what is its measure of angle B?
B over 5. Wait. Oh, 71.7.
Alright, so the tangent of B, which is 71.7, is going to be opposite over adjacent. That's going to be side B over our adjacent side, which is 5. Do you guys see how I set that up? We went from this angle and said, we want to find this side. That's our opposite. We know this side, so let's do opposite adjacent. That's tangent. Now we're going to try to solve for B. It's being divided by 5, so what do we do?
We're going to
So guys, on your calculators, will you do 5 times the tangent of 71.7?
15.1.
And then Eleanor said she got 15.1. Can someone confirm that? Yes, thanks, Isaac. So there we go. Now we have found our 2 missing angles and our missing side. Isn't that great?